Okay, so this is take 2 because the first one didn't save. So we're doing it's called more or less, and we're going to be able to solve and graph and write systems of inequality. So in this lesson, there's nothing new that you're going to learn. All of it is something that you already know how to do. Okay. So in this jumpstart, go ahead and try this one on your own. The biggest thing that you want to know is this. This is your job as a mathematician. Since all the coefficients are exactly the same, what accounts for the difference in the solution set? So as you graph these, you should know what is the thing that is determining or distinguishing that makes each of those. So by today, you'll be able to solve systems of linear inequalities and answer the question, how do I interpret the signs such as greater than, less than, greater than or equal to, and less than or equal to when determining what to shade as a solution set in an inequality? So when we're when we're graphing an inequality, we're just graphing an inequality. Okay, for you guys, because you already know how to graph an equation. The new thing here is graphing an inequality. So the same thing goes. I'm going to use Desmos to make this process go a little bit faster, but whichever method is your favorite for graphing an equation, whether that be y equals mx plus b, whether that be graphing your intercepts, plugging in points, whatever it is, you should already know. In your head, you should already have a picture of what this should look like. For example, this symbol right here should tell you where you should be shading above or below the line based on what you see, right? Same thing goes here, if you should be shading above or below. And then you should also know whether the line is dotted or if it's solid. Okay. And if you don't know, graph it and then play around and be like, oh, that's what that thing does. For example, negative 5x plus 3y is less than or equal to. You literally type less than and then the equal to, and it turns into that. You get 45. Now, let's go over here and erase our equal to. What just happened? I'll put the equal to back. I'll erase it. What's the only thing that changed? Yeah, so you should have noticed right here, this dashed line becomes a solid when we get an equal to sign. So logically speaking, right, because we made that change in this equation here, look at what happens here, right? Okay, fine. So what if we change this to a greater than or equal to? Oh, that's what I thought. It shades there. So you should be kind of keenly aware of what each of the symbols does. So there goes that. The next one is 2x plus 3y is greater than 24. And so you get this system of inequalities here graphed. You see a dash line here. You should have already predicted that in your head. Oh, that's a dash line. You should have already predicted, oh, I think it goes above. And then you would check your solutions to make sure. Just so we're on the same page, the solution set is all the points in this section that are shaded twice. So for example, this point, yes. This point, yes. This point, yes. The points that you must concern yourself with are the points that are along this border. If it's on the dashed line, is it a solution? So if you don't know, pick that point, which is right there, and then plug it into both of them. It should be a true solution for both. So for example, I'm going to grab this. Actually, I don't need all that. I only need this part. I'm going to grab this and put that right here. And then I'm going to use that point that we just got, which was 0, 8, and see if that's a solution. So here's 0, here's 8, and it says 24. So for this one, 24 is less than or equal to 45. So it is a solution of the red. It's a solution of the red. So if you picked a point on this dashed line, it is shaded red. So we're good. Okay. So then what about this one? Is this one going to be a solution for 0, 8? So then here's that. And I'm going to erase that and put 8. And I'm going to put this and put 0. And it says 24. And then you go back up here. Is 24 greater than 24? And the answer is no. So this guy, Miss Johnson, not a solution. Yes. Explain to me why this is not a solution. Go ahead. Okay. The reason why you should have said it goes something like this. It worked for one of them, but it didn't work for all of them. Therefore, it is not a solution to the system. So it's really easy to pick here, yes, here, yes, here, yes, here, yes, here, yes, here, yes, here, yes. Off my screen, yes. Here, no. Why not? Because it didn't work for all of them. Same thing goes here. Same thing goes here. And the border of the solid one, that's what I want you to think about. What do you predict? Yes or no? Is this a solution? What do you think? Yes or no? And so the answer is, I don't know. Let's plug it in. So I plug it in here. It's 0, 15. So 45. Yeah, 45 is less than or equal to 45. So we're good. So I'm going to plug it in here, 15. And I get 45. Right? Did I do that? Yeah, I did. So is 45 greater than 24? And you're like, yeah. So that is a solution. So people along the solid line are understood as solutions versus people along the dash lines are not solutions. Okay? So keep that in mind when we're doing this, okay? The other thing that I'm also going to ask you to, and you'll see it in one of these couple ones, is can you go backwards? Can I show you a picture of a graph and can you lead me to this kind of understanding? And your answer should be yes, right? If you know how to do something forwards, when you'll really understand how to do it if you can do it backwards. Does that make sense? Not everything, but most things. All right, so number 2, you're going to be left to do that one on your own. You're going to graph it. You're going to copy your graph here and make sure that you're really good on understanding. This point here is the point -3, 10 a solution to the system in problem number 1. Why or why not? So let's go back. Is -3, 10 a solution? So let's look at it. -3, which is this guy here, up 10. What do you guys think? Do you think this point is a solution? Yes or no? Do you think that point right there is a solution? Yes or no? So for those of you who said, I don't know, Miss Johnson, I don't even know how to tell, I'll give you a hint, hint, nudge, nudge, wink, wink, right? And the answer is, let's go look. So we're going to go -3. It's a 10. So is 45 less than or equal to 45? The answer is yes. And I'm going to go here again. -3 and 10. And I get 24. Is 24 greater than 24? The answer is no. Now, why isn't this a solution graphically? Well, because it's on the dashed line, right? Dashed lines are not solutions. Anybody on the dashed line is not a solution. So go ahead and give your answer to this. Give a really detailed explanation of why this is good. Like the more you work on like creating sentences of understanding from your perspective, the better you learn it. So the people who like do, that's why I have you guys do flip grids, right? The reason why you do flip grids is because you're talking about your understanding. There should be a point at which you're like, wait a second, I don't understand this part. And that's where I come in. That's when you ask, hey, Ms. Johnson, I understood to this point, but I'm really having a hard time explaining this one part. So make sure you are okay with that. So this is the problem that I was referring to earlier, that you're going to have to learn how to go backwards. So for the most part, you guys already know how to do this. It's graphing a line, but going backwards. So for example, most of you will choose to use y equals mx plus b, right? So where b is the y-intercept and m is your slope, right? So I am going to, let's see, I wanted to... So the easiest way to graph this is, or to write this is, I'm going to find my intercept. So that's 10. So I'm going to erase b. Actually, I'm going to write that again. I'm going to go y equals mx plus 10. Now, the reason why I'm putting 10 there is because that's where the line intersects the y-axis. And then I'm going to find my slope. Now, my slope looks like Like you got to find a pretty good point, which I think this is a really good point right here. See how it goes to the corner, right? And so what I'm going to do is I'm going to draw my slope out, which my slope goes from here to here, right? And then it goes from here to here, right? All the way over, but I couldn't reach it. So that slope is -5. That slope right there is -5 divided by 1, 2, 2. So that's pretty big writing. So just imagine. So instead of here, I'm not going to write m. I'm going to write -5 divided by 2. And that's my slope. So I'm going to take this equation and I'm going to graph it and check to see if it did what I wanted it to do. And I'm like, yeah, doesn't that look like this? Yes, it does. So now I want to shade it. How would I shade this side here? And if you don't know, just put a symbol. Did you want to shade this side? And you're like, no, I wanted to shade the other side. So what would I need to change that? Logically speaking, what would I need to change that? I would need to change it to this. See how now it's on the right side? And you're like, oh no, this is the dashed line. So what do I need to add? Very good. An equal to sign, right? So that's one of them. I'm going to make you do these two, like really do them. Because when you really do them, then you'll really be able to understand. I'm just going to tell you right now, you will have one of these on the test. Right? So go ahead and do those two, and I'll meet you back here for when you're done. Okay. So what I want to do now is I'm going to show you the second line, which is going to be this one. And so I'm still going to write y equals mx plus b. Right? My b in this case is still 10, so I'm going to change that out for a 10. And I'm going to look for my slope. Now my slope looks good right there, and it looks good right there. So when I count up, it looks like I'm at 1. So I went up 9, and I went right 6. So I went up 9, so 9 divided by 6. You can also simplify that fraction if you'd like. I'm not going to because it's still the same equation, so I'm comfortable with that. And so there's my equation so far. That looks like that, right? That looks like the top of that part right there. So now what I'm going to do is I am going to change this symbol. And again, if you don't know which symbol to use, guess what? Just guess, right? Okay, I'm going to try to use this one instead. So I'm going to go this way, erase that. Oh no, I did it on the wrong side. Of course I knew that. Sorry. So I need to go to this one here. Oh, that's so much better. And then you do your last one. So I need to switch this one to less than or equal to. All right. So then my last one, I'm going to still do the same thing. I'm going to go y equals mx plus b. In this case, it looks like b is 2. So I'm going to erase that and put a 2. And then I'm going to change my slope. My slope looked like it's good from here. So I'm going to go up to 1. Is that 1, 2? Is that 2? Or is that just... No, that's a bad point. So I'm not even going to use that. I'm going to go right here to the y-intercept. I'm going to go up 1, right 6. Up 1, you should see that little triangle on top of that line. So it's 1, 6. If you don't know where 1, 6 comes from, go back into our videos and look for one that is talking about slope or how to graph a line. So there he is. So I am going to copy this down again. I'm sure a lot of you got that right. I love it. And then I already know that it's a solid line, so it's between these two. I don't know above or below. I'm just going to try to put that one and see. Oh yeah, that's right. So there goes my answer, and it's perfect, right? If you had any questions, if you had to pick something, okay, what was the hardest part in this? It's actually you guys remembering in the past how to pull an equation off of a graph. These symbols here, less than, greater than, that's just you figuring it out because you can always check. According to this, 0, 0 should not be a solution, right? So you're going to check a point that maybe is a solution and then plug it into all three and make sure that that works. Like for example, 0, 5. 0, 5 should work every single time. So if this is 0, that would be 0 plus 10. So that's 10 is greater than 5. Yep. So that's 0. So this whole side is going to be 10, and this is going to be 5. So yeah, 5 is less than 10. Again, this is 0 plus 2 is 2, and is 5 greater than 2? Yes, it is. So see how I just proved that this point right here is a solution to the system. Okay. Next question. It says, Amanda is examining Frank's work on problem 4 when she exclaims, "You've written all of your inequalities backwards. The solution set to your system would look like this." So what do you think about Amanda's statement? How would you articulate this? How would you articulate this right here that and tell Frank like you're wrong? Because we already know what the answer is. The answer is inside. How would you help him see that his answer is wrong? And do you agree with Amanda's statement that you wrote it backwards? Okay, so I'm leaving this one for you. If again, this is one of those ones where if you want to explain something else during your exit ticket, this could be your exit ticket. Okay. All right. So this one is the problem that I'm going to leave you to do on your own, because we've built up all of these problems about Carlos and Clarita, and the money constraint, the space constraint, the time constraint with feeding and pampering the dogs. So I want you all to have the opportunity to read this problem and make sure that you know how to do it, because this is what you're going to have to do during a test. Write and solve a system of inequalities that Carlos can use to determine possible combinations, right? Based on your work, suggest at least 3 different recipes, okay? So here, what we're going to want to do is make sure that you understand how to write the inequalities. All right, the last thing I wanted to do was talk about takeaways. So all they want you to do is describe a procedure for modeling a context using a system of inequality as constraints. So the biggest thing here, what did you get out of it? And write a sentence. Like, what was the part that's going to give you a hard time in terms of understanding and proving that you're right? Right? Okay. Well, with that being said, thank you for listening. Hope you have a great day.